Perceptron, where we have one input layer, the hidden layer, and your output layer. And since we have only one node in the output layer, that means this is a binary classifier. In the hidden layer, we have two nodes and one node in the output layer. All the links that are coming from one layer to the next layer, for example, from your input layer to your hidden layer, they will have links, and these links will have the weight values. And the notation for writing these weight values is that you first write the node in this layer where the calculation is being made, because the input is coming from layer 1 and into your node 1, we write W1, 1. When the input is coming from X2 into your first node in the hidden layer, we write it as W12. So Wij, so I is the layer where we are doing the summations, the node, and J would be the preceding layer. So for example, W21 means that the input is, the weight value is for the link between node 2 in this layer with first in the previous layer. So in this case, the first layer is your input layer. But if you look in this part, the link weights that we have, W32 means that for node 3, we call this the node 3, the input is coming from node 2. So make it a little bit clear. W32 means the input is coming at node 3 from node 2 in the previous layer. So this is your node 2. W31 means the input is coming at node 3 from node 1 in your previous layer. So this is the representation for your weight. Now we see another H symbol. So the output from the hidden layer is represented as HIs. So first hidden layer output is H1, second hidden layer output is H2. And this works as the input for this next layer, that is the output layer here. So now H1 is treated as the input, that is multiplied with your weight value. In the neuron, you have a summation part and you have a nonlinear transformation. So this transformation transforms the summation of your input, as we discussed in the beginning of this lecture. Now, mathematically, how do we represent that? So what is H1? The output from hidden node 1. And what do we have? The function, we know that the function is represented by h of x 1 plus exponent minus f of x. So the function here we have is, look at the output here. It is the combination of what? These three links. Okay. So W11 multiplied by x1, W12 multiplied by x2, and then we have this W0. Now we will look at H2, this. It is a summation of what? W21 multiplied by x1, W22 multiplied by x2, and W20, right? Then we do the summation. This is the summation part. And this is your f of x part, the transformation part. This f. Oh, sorry. We are here. So we have our H1 and then we have our H2, and you can see it is going as the input for your final layer, the output layer. So the input for this summation would be a multiplication of these two, and this. And what it is, was it multiplied by? It is multiplied by 1. So we have W31 multiplied by H1, W32 multiplied by H2, and W30 multiplied by 1. That is the summation part. And then the transformation function is f of x. So that is how you can represent that. Graphically, how you can present your multi-layer perceptron. Here we have given an example of only 3 neurons. And the final mathematical form of the output would be W31 is multiplied by your H1, W32 is multiplied by your H2, and then W30 is multiplied by 1. Here we call this the bias, and we will come across why do we have a bias value and what can be the good options for choosing your bias value. And from previous logistic regression examples, we know that this bias is W0. So for each layer, we will have one bias value. To conclude what we have studied, the structure of multi-layer perceptron is composed of input layer, hidden layer, and the output layer. In the input layer, we simply pass the input values to the next layer. What is the next layer to the input layer? It is the hidden layer. So how many nodes should be there at the input? These are the input. That is depends on the given problem. So the number of nodes should be equal to number of inputs. And the hidden layer, we could have multiple hidden layers. So here we have 2 hidden layers in this example. And the number of nodes should be defined. So we have to define a model, and it should have a well-defined number of nodes for the input and the hidden layers. And finally, we have the output layer, and depends on your problem, what kind of problem you have defined. Is this a prediction problem? Is this a classification problem? Binary classification, multi-label classification, prediction, multiple predictions, or only one prediction? Depends on your problem at hand. So the number of output node depend on number of outputs that you have. The number of input depends on nodes depend on your input, and the hidden layer you have to define yourself how many nodes will be there. And there are some general rules that we can use to define how many nodes in the hidden layer. There are some general rules that we can follow, and also we can define what best suits our example at hand. To start with, we can define the number of hidden nodes that gives us the best accuracy or best performance. So multi-layer perceptron belong to the artificial neural networks. They are the tools. They are defined based on the biological brain, the human brain, the animal brain, and they can learn nearly anything. The types of artificial neural networks are what we have studied today. The basic concept is multi-layer perceptron, which is the base. Then we have self-organizing neural networks. And some of the other names that you will come across for the multi-layer perceptron are feed-forward neural network or multi-layer feed-forward neural network. What we studied was some of the functions that we can define. For example, a Boolean function, we defined a two-layer perceptron. For a continuous function, we would need again a two-layer perceptron. An arbitrary function, maybe we will need three-layer perceptron. We can build our own multi-layer perceptron, which gives us the required input-output pairs. For example, in this case, we can have the input layer, then the first hidden and the second hidden layer, and then the output. The first hidden layer would define these lines. Then the next defines the convex function, and then we combine the convex functions. Okay. We end our lecture here, and we will continue with this lecture in the next lecture. If you have any questions or you have any queries, please write a question in the comments, or you could address them in the lecture that we have in the next week. Or you could write an email that is mentioned in the lecture number 1, and I will be vigilant to give you a response as soon as